Well, hello. Today we're going to be talking about division. Now, many of you learned division around when in your elementary school years, and you saw maybe this bracket-looking thing where you had this larger number inside and a smaller number outside. They told you that this was the larger number divided by the smaller number. Um, in this instance, that's what we're going to talk about. But we're also going to look at it in another form because we don't use this notation um, pretty much at all. Any formula that you might be using when calculating something for your job or your career or in other classes, they don't write division in this format. But a lot of times, this is useful to write it this way for people to divide correctly and to see where their answer is. Now, when it comes to division, the first thing that's important, and it's important throughout the entire process, is estimating. Making sure you're able to estimate what you think the answer should be around, because you need to be able to do that when you're doing these division problems. And we're going to be looking at an example, and I'll keep bringing estimation up while we're looking at the example. So first off, we have 4,505 divided by 6. 4,505 divided by 6. So first thing you want to do is kind of get an estimate of what our answer should be around or in between. We know that 6 times 700 will be 4,200 or 4,200. We know that from our multiplication facts. And those are things that we want to remember. So we know that this answer must be greater than 700. We also know that 6 times 800 will be 4,800. So we know that this answer has to be less than 800. So our answer is going to be somewhere between 7 and 800. And honestly, you could even go a little step further. Some of you may say, well, that's 45. And that's in between 42 and 48. It's right in the middle. So our answer should be somewhere in the middle then. So somewhere around 750 maybe. So you can estimate pretty well of what your answer should look like. We know it's not going to be greater than 800. We know it's much less than that. So it's in the 700s. So that actually helps us out with the first digit. So when you were dividing, you were told generally to begin by saying how many times can 6 go into the first number? Or can you do the first digit divided by 6? Well, we can't do 4 divided by 6 and get a whole number. Because remember, we're doing whole number division. However, if we change 4 to being a 10 and then add on the next digit, we're looking at 45 now. We can do 45 divided by 6, and there'll be some left over, but we can do 45 divided by 6. And as we already said, that would be 7. So the first step in doing whole number division is dividing. Okay. So first, we divide. Okay. Now, the second step is to see, well, how much is exactly left over? How much is the 7 going to be taken care of? Well, to do that, we need to multiply. So you would do 7 times 6, and we would get 42. And so step 2 is to multiply. And then we subtract to see what the remainder would be there. So we subtract 45 minus 42, and we get a 3. So the third step is to subtract. Okay. Well, once we subtract, we then have remaining digits that we must use. So to use them, we need to bring them down. So sometimes teachers teach to bring everything down. Sometimes people teach to bring down one digit at a time. Either way is fine. Personally, I prefer to bring down the remaining digits, all of them, so you can keep track from there instead of having to go all the way back up. However, most of you are used to this form and this notation of bringing down one digit at a time. So therefore, I'm going to use that. Also, many books use it that way as well. So once you do this, so that was the fourth step, we brought down the next digit. And then the fifth step is to repeat until there's nothing left. So until there's no remaining digit or the remainder is less than the divisor, the number we're dividing by. Okay. And of course, this is probably too small for you to read, but just writing it down just so you can know what we're going through. So again, our first step was to divide. Then we multiplied what we received. Then we subtracted. And this also is a caveat to help us catch things, because say we had picked 6 to start off. 6 times 6 would have been 36, and we would have subtracted this, and we would have gotten 9. And 9 would have been larger than 6, so that means that we probably can go up another number with dividing. And so that's the reason why we subtract. And then we bring down the next digit, and then we repeat the process again by dividing again. Now, I've heard young children nowadays, they have a little saying to help them remember how to do this. So they have a family in order, and I like to think of it as my family because it actually fits. So you have the dad, the mom, the sister, and brother, and that was the order in which how old we were. So you have the dad first. So divide dad, multiply mom, subtract sister, bring down brother, and then they keep doing it that way. It's just a funny little thing to help people remember. So let's just finish this division problem. And so we have 30 divided by 6, and 30 divided by 6 is 5. Remember we said we should get somewhere between 700 and 800, and we knew that this number would happen to be halfway between those two answers, so maybe around 750. So far, we're looking good. So we divide it. Now we're going to multiply again. 6 times 5. 6 times 5 gives us 30. And we're going to subtract. And we get 0. And sometimes people get to this point and think they're done. Well, we're not, because we have digits remaining. So we still have to bring down. So if you remember that dad, mom, sister, brother thing, you remember there's 4 steps to division. That will prevent you from saying, oh, I'm done because I have 0 here. Because that is a common mistake that's made. Always still have to bring down. So we bring down, and we get this 5 here. So we're really doing 5 divided by 6. And 5 divided by 6 is 0. Notice how we still had to do that one because it was still a digit that was remaining here. But you can't do 5 divided by 6, so the number would have been 0. And in the beginning, when we did 4 divided by 6, you can put a 0 there as well. However, having a 0 in front of 7 doesn't change the value here. So that's why traditionally you see that people don't put that there. But anyway, so we have 5 divided by 6, we get 0. Now we multiply down. So 6 times 0 is 0. We subtract, we get 5. And there's nothing else to bring down. So now we are done. There's nothing left to bring down. There's no other digits to bring down. And so therefore, this 5 is what's called our remainder. So a lot of times people put an R, capital R or lowercase r in front of it, or they'll put it next to the answer, the quotient. So we can put that up here, R5. So 4,505 divided by 6 is 750 with the remainder of 5. And that's what we got with this answer. So this is how you were traditionally taught how to divide, and many books, many videos and things like that. And you'll see in the rest of this section that this is how traditionally we divide, because it's easier to see the process in doing so. However, I would like to show you another way that division can be done. And this way, I think is actually faster for some people a lot of times, especially when they get into looking at higher numbers or where they're so stuck on, like, for example, I said earlier that let's say we chose 6 at first. Well, using this other method, it's okay to choose a different number first. It's perfectly fine. And it is more so what division is actually doing the entire time. So it's not going to be different from what we just did. However, it is going to seem different. And again, if you want to stick to the traditional method, that is absolutely fine. You do what's going to be best for you. Because once again, any class is always about you deciding how this information and how you're going to use it. It's not about doing everything the same way that your teacher does it. It's about making sure that the method behind what you do is correct, though. So here's another way to divide. We'll use the same thing. And I actually want to do this because I wanted to show you that this is division. So here you see 4,505 divided by 6. Well, that doesn't look like what we just did, nor does it look like this symbol here. Well, That's because this is division, and this is what you will normally see for division. You won't see the symbol we looked at, nor this one as often. Funny thing about this, with the two dots and a line between it, it is representative of writing it in this form here, which many of you will say, oh, that's a fraction. And we'll talk about fractions in another section, in another content page, in another unit, another chapter. But fraction is nothing but division. And I'll say, you'll hear me say that a lot, especially as we move forward with that. So how do we divide then using seeing it in this form? What is another way that you have for us, Professor Stevens? Well, another way to divide is to pick out the pieces that you already know and then continue on with the remainder. And you'll see an example exactly what I mean. So for starters, we knew off the bat, because we were estimating, right? We knew that 6 goes into 4,505 at least 700 times. We knew that off the bat. We knew that just because 6 times 7 was 42. Well, say you didn't know that. I actually I work with and tutor young children a lot, and a lot of times, for whatever reason, when it gets to 7 or actually, yeah, 7's the one that usually it happens with, they forget the multiplication facts for 7. And so a lot of times I just tell them, well, find something that you do know, especially when we're doing division. Why don't you remember? And so they'll go lower. So 5 or 3 or 2. Most times people will pick 5 because 5's a fun one for them, because they can count by 5s, and 5s are just easy for them. So let's just say we know it goes in at least 500 times. So when we divide this, we're going to put our 500 down. Well, how much will be left over? Well, if we did 500, took 500 out of here, then that would have meant that we're really subtracting 3,000 out, right? Because 6 times 500 is 3,000. And I'm actually going to write that a different way so that you can see that. So we're going to change this to 3,000, because we can divide that by 6 and get 500, plus how much would be left over? 1,505. And so we divide this entire thing by 6, each part. So this part will give us 500 left over, plus whatever 1,505 divided by 6 is. So far, so good. The next step here would be to continue. Well, what else do we know can go in here? Well, someone may say, oh, I can definitely see 12 because I see the 15 there in front. I can see 12. I know 6 goes into 12. So then you say, okay, well, we already have the 500, and I'll just circle them for now instead of keep writing it. But we already have the 500 done, so if we change this to being 1,200 plus 305 divided by 6, well, we know 1,200 divided by 6. We know that one off the top of our head. And so we have that extra 200 that we can bring out, plus the 305 divided by 6 left over. Okay. Some of you may be like, oh, well, I definitely see the 30, so let's go from there. So if we do that, when we look at 300 plus 5 divided by 6, well, this part will give us 50 plus 5 left over 6. And so in total, if we take all those pieces together, we can't divide that anymore. So that's going to go in our remainder. So we have 500 plus 200 plus 50 plus 5 over 6. So in that case, we get 750 with the remainder of 5 over 6, or 5 out of the 6. And some of you may say, that looks like a mixed number. And we will look at those later. But this is actually what a mixed number is. This is where it comes from. It comes from just doing whole number division. You do the whole number part, and then you take the remainder to get your quotient. You take the remainder and put it over your divisor, over the number you were dividing by. And so there we have it. We have 2 different methods to divide. You can do the traditional way, or you can do this way, which is kind of like a guess and check way. It's like starting as low as you can without having to, a lot of times when you were dividing the traditional method, you would try a number first and it would be too small. Well, using this method, it doesn't matter if it's too small. You just can continue on from what's left over. And that's actually why I like this method. And a lot of times when I'm dividing large numbers divided by large numbers, I use this method because it's easier for me to estimate and then just subtract from the remaining part and keep doing that until I can't divide anymore. Like what we got here, the number on top was smaller than this bottom one. And then just add the pieces that you have together. It's a lot quicker. It's a lot faster than trying to say, oh, let me try multiplying by this number. Oh, let me try multiplying by this number. So yeah, so that's division, and I will see you again soon.